Okay, I'm going to work through some of the homework problems from the assignment in 2.4 in AP Calculus. It now goes 7 to 31 odds and 43 to 95 odds. So for number 47, the derivative of cosine is negative sine of the same angle times the derivative of the angle. So it's negative 4 sine of 4x. Now that one is, like I say, pretty straightforward. No product rule, no quotient rule, just a straight chain rule. Now I have a product, so I'm going to have to use a product rule on 53. So I'll bring the sine down times what's the derivative of cosine? Negative sine of the same angle times the derivative of the angle, plus bring down the cosine, now times what's the derivative of sine? Well, it would be cosine, same angle, times the derivative of that angle. So this is a negative 2 sine squared 2x, because you have sine times sine, plus 2 cosine squared 2x. It's probably better to put the positive one first, and then minus, because it's negative, 2 sine squared. Can you factor out a 2? And what's that leave me with? Cosine squared minus sine squared. Anybody know this identity? No, sine. The reason being, this is an identity. Cosine squared minus sine squared becomes cosine of 2u, and doubling 2x becomes 4x. It's just one of the more obscure trig identities. Now on to 69. To find the derivative of e to a power, you're going to do e to the same power times the derivative of the power. So this would be the derivative for 69. For 75, it would be advantageous to know your rules. There is a rule in logarithms that allows you to pull the exponent out front. So this becomes x squared times the natural log of e. E to what power is e is 1. So really, this whole thing is just a disguised form of x squared. A lot of people just think natural log and e eliminate each other, leaving you x squared. And the derivative of x squared, therefore, would be 2x. After 75, let's look at 83. This is a product, so we might need to use the product rule. So I'll bring down the first part, the e to the x, times the derivative of this. Derivative of sine is cosine, plus derivative of cosine is negative sine. And you're right, I'm not showing you everything. Derivative of sine is cosine of the same angle times the derivative of the angle. Plus the derivative of cosine is negative sine of the same angle times the derivative of the angle. Plus bring down the sine x plus cosine x times what's the derivative of this part now? The derivative of e to a power is e to the same power times the derivative of the power. So I think I can factor out an e to the x. If I factor out an e to the x, I have cosine x minus sine x plus sine x plus cosine x, which I believe becomes 0, and anything times 0 is 0. Let me check my answer. Okay, I'm wrong because these drop off. Cosine x plus cosine x is what? 2 cosine x, and so my answer was this for the derivative. 83, then we have 85. You have a choice on 85. You could do the derivative of natural log of u is 1 over u times u prime, or u prime over u. If u is x squared, if the u is the x squared, what would be the u prime, the derivative of that? So you'd simplify and get your answer. I'd rather you know your properties. Can I pull the exponent out front? And now do I know what the derivative of natural log of x is? 1 over x times the derivative of x. So either way, we should end up with an answer for the derivative that is 2 over x. Now in 85, I was able to pull that exponent out front because that's only the argument was raised to the power, unlike 87. Some people will try to pull this out front, but that's not the property. You're breaking the rules. So to find this derivative, you have to use the power rule. Power times base to the 1 less power times the derivative of the base. So it would be 4 natural log of x quantity cubed, the whole thing over x. And that would be the derivative for 87. Okay, after 87, here we have a 89. It is a logarithm. Do you know the properties of logarithms? Can I break this up into log of one plus the log of the other? Because I did log of a times b to be log a plus log b. I called the square root a 1/2 power. Why did I do that? So that I can rewrite it again. Notice I still have not taken the derivative yet. I'm going to pull the 1/2 out front using the third property of logarithms there. And I have this. Now I'm going to do the derivative. U prime over u, or 1 over u times u prime. The derivative of natural log of x is 1 over x. Here you could do u prime over u, and this would give me what? X over x squared minus 1. Again, that's u prime over u. That's a derivative. If I was to do the derivative of the natural log of u, it could be u prime over u, which is what I did. Now to get a common denominator, this needs an x squared minus 1, and this needs an x. So what would that make my common denominator? X times x squared minus 1. Over here I get x squared minus 1. This over here gives me an x squared. X squared plus x squared is 2x squared. And again, you'd have this as your answer. Okay, after 89, I think we're going to try 93. This is a quotient, so I'm going to do a quotient rule. Quotient rule says the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So this simplifies to t minus 2t times ln of t all over t to the fourth. I would take a t out of the top, a t out of the bottom, and I would have my answer. 1 minus 2 ln t all over, I think, t to the third. That's one answer. 1 minus ln of t squared all over t to the third is probably a better answer. That's if you know your properties. That 2 could go back up as an exponent. Again, on an AP test, multiple choice, clickers, whatever, there's not going to be 2 correct answers. You're going to have to determine which is the correct version, probably written in a different form than you have it. So you have to be able to manipulate them. Let's see if I can get another one in here. How about this? What is the square root? Do you agree this is b to the 1/2 power? Can I pull this out front? And is there a property for the log of a quotient? And again, I'm going to use the log of the top minus the log of the bottom. At this point, I might find the derivative a little easier. U prime over U, U prime over U. What would be a common denominator between these? Would it be x squared minus 1? This is missing what? X minus 1. What is the other one missing? This is missing an x plus 1. Don't forget to use parentheses when you subtract. X and a negative x is 0. Negative 1 and a negative 1 is a negative 2, right? So you have a negative 2 over x squared minus 1. Could the 2's cancel? Could the negative be used to reverse the subtraction? I think your answer could be written in any of these last couple forms. And somebody had asked number 61. 61, I'm going to keep the 1/4 out front as a constant. And realize that this means quantity squared, right?
Yeah, it's 2 theta.
It's 2 theta? Okay, so what I do is I do power times the base to the 1 less power times the derivative of the base. Derivative of sine is cosine of the same angle times the derivative of the angle. 2 times 2 is 4. 4 times 1/4 is 0. That leaves me with sine 2 theta, cosine 2 theta. Or maybe if you're really good, I believe there might be an identity that changes this. Let me see what they have for an answer for 61. Bear with me. Okay, I'm wrong. My identity is incorrect. This is the answer, I hope. I hope these help. Good luck.